Ever looked up at the night sky and thought, man, I could make a better planet than that? Okay, maybe not. But seriously, have you ever wondered how planets, those massive spheres of rock, gas, and the occasional ring system actually get made? It's not like there's some cosmic IKEA out there with step-by-step instructions. Building a planet is a messy, chaotic, and mind-bogglingly long process. We're talking billions of years, folks. Imagine a cosmic construction project that makes the pyramids look like a weekend DIY project. But the universe, in all its infinite wisdom and weirdness, has figured out a way. So buckle up, space cadets, as we take a wild ride through the science of planet formation. We're about to unravel the mysteries of the universe, one cosmic dust bunny at a time. Picture this. A vast, swirling cloud of gas and dust like a cosmic smog cloud just hanging out in space. Not exactly the most glamorous start for a planet, right? But hey, even Beyoncé started from somewhere. Probably not a dust cloud, but you get the point. These clouds, called nebulae, are like the maternity wards of the universe. They're filled with hydrogen, helium, and all sorts of other elements just waiting to become something amazing. Think of it as the ultimate cosmic recycling program. Now, these clouds are pretty chill most of the time, just vibing in the vastness of space. But something happens that throws this whole system into overdrive, a supernova. Basically, a star explodes, and it's the biggest, baddest fireworks show in the universe. A supernova isn't just a pretty light show, it's a cosmic shockwave that sends ripples through space. When these shockwaves slam into a nearby nebula, things get interesting. The dust and gas start to clump together, like cosmic dust bunnies under your bed, but on a much grander scale. These clumps, called planetesimals, are the planetary seeds. They're still tiny, maybe the size of a grain of sand or a small asteroid. But they're on the move, bumping into each other like bumper cars at a cosmic carnival. Most of the time, these collisions result in bigger planetesimals. It's like playing cosmic Lego, but instead of snapping pieces together, you're smashing them with the force of 1,000 suns. Don't try this at home, kids. As these planetesimals grow larger, they start to exert their own gravitational pull. Gravity, as you may know, is a bit of a drama queen. It's all about attraction, pulling things together like a cosmic matchmaker. The bigger the planetesimal, the stronger its gravitational pull, and the more it attracts even more material from its surroundings. It's like a snowball effect, but instead of snow, we're talking about rocks, ice, and gas. Over millions of years, these planetesimals can grow from pebble-sized objects to planet-sized behemoths. It's like watching a cosmic time-lapse video, but instead of a flower blooming, you're witnessing the birth of a planet. Pretty epic, right? Section 5. Sizing up the competition Earth versus the new kids on the block. In this section, we will explore the fascinating diversity of planets in our solar system and beyond. Now, planets come in all shapes and sizes. From the tiny rocky worlds to the massive gas giants, the variety is truly astounding. We've got gas giants like Jupiter, which is so big you could fit over 1,300 Earths inside it. Talk about feeling inadequate. Jupiter's immense size and powerful gravitational pull have a significant impact on the solar system, influencing the orbits of other planets, and even protecting Earth from potential comet impacts. Then there are rocky planets like Earth, our humble abode, which is just the right size for a nice cozy biosphere. Earth's size and distance from the sun create the perfect conditions for life as we know it, with a stable climate and liquid water. The size of a planet depends on a lot of factors like how much material was in the original nebula and how close it formed to its star. The process of planetary formation is complex and involves the accumulation of dust and gas over millions of years. It's kind of like baking a cake. The ingredients and the oven temperature will determine the final product. Just as a cake's texture and flavor depend on the right mix of ingredients and baking conditions, a planet's characteristics are shaped by its formation environment. But no matter their size, all planets share a common origin story. They were once just tiny specks of dust, dancing in the cosmic ballet of creation. Over time, these specks collided and stuck together, gradually growing into the diverse worlds we see today. This process, known as accretion, is a fundamental aspect of planetary science and helps us understand the origins of our own planet. Section 6. Gravity. the ultimate wingman, and planet maker. We've talked about gravity's role in attracting material, but this cosmic matchmaker has another trick up its sleeve shaping planets. As planets grow larger, their own gravity starts to pull them into a sphere. It's like the universe's way of saying, get in line everyone, and form a nice round shape. Now some planets are better at following directions than others. Gas giants, with their massive size and swirling atmospheres, are pretty good at achieving that perfect spherical figure. Rocky planets, on the other hand, are more like cosmic potatoes, a little lumpy and bumpy. But hey, nobody's perfect, right? Even with a few imperfections, planets are still pretty amazing feats of cosmic engineering. Section 7. Exoplanet hunting, finding new cribs in the cosmos. Now, you might be thinking, okay, that's cool and all, but what about planets outside our solar system? Are there other worlds out there waiting to be discovered? Well, my friends, that's where things get even more exciting. The universe is vast, and our solar system is just a tiny speck in the grand cosmic ocean. With the help of some seriously powerful telescopes, astronomers are discovering thousands of planets orbiting other stars. We call these exoplanets. These telescopes, like the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, TESS, are our eyes in the sky, scanning the heavens for new worlds. These exoplanets are like the cosmic equivalent of pen pals. Each one has its own unique story, its own set of characteristics that make it special. We can't visit them yet, but we can learn a lot about them by studying the light from their stars. This light carries a wealth of information like a cosmic fingerprint, revealing details about the planet's atmosphere, composition, and even potential signs of life. It's like trying to figure out what's in a gift box by shaking it and listening carefully. Every wobble and shift in the light tells us something new and exciting. And let me tell you, the variety of exoplanets out there is mind-blowing. We're talking super-Earths, hot Jupiters, mini-Neptunes, and even rogue planets that drift through space without a star to call home. There are even planets that orbit two stars, creating a double sunset scenario, like something out of Star Wars. Imagine standing on the surface of such a planet, watching two suns dip below the horizon. The possibilities are endless and the discoveries are just beginning. Section 8. Are we alone? Planetary formation and the search for life. The universe is vast, with billions of stars and even more planets. Each of these planets has its own unique story of formation, a tale that begins in the swirling clouds of gas and dust that make up a protoplanetary disk. Discovering all these exoplanets begs the question, is there life out there? With each new discovery, we inch closer to understanding the potential for life beyond Earth. These exoplanets, orbiting their distant stars, offer a glimpse into the diversity of planetary systems. Are we alone in this vast cosmic playground? The sheer scale of the universe, with its countless galaxies and stars, makes it hard to believe that Earth is the only cradle of life. The search for extraterrestrial life is not just about finding aliens, it's about understanding our place in the cosmos. While we don't have a definitive answer yet, sorry to disappoint, understanding how planets form is crucial to figuring out if they could support life. The process of planetary formation is complex, involving the gradual accumulation of material over millions of years. By studying this process, scientists can identify the key factors that make a planet habitable. For example, we know that liquid water is essential for life as we know it. Water is a solvent that facilitates the chemical reactions necessary for life. On Earth, wherever we find water, we find life, from the deepest oceans to the driest deserts. By studying the size, composition, and orbit of exoplanets, scientists can determine if they might have the right conditions for liquid water to exist on their surface. This involves analyzing data from telescopes and space probes, looking for signs of atmospheres and temperatures that could support water. It's like playing cosmic detective, piecing together clues to solve the ultimate mystery. Are we alone? Each piece of data, each new discovery, brings us one step closer to answering this profound question. The search for life is a journey of exploration and discovery, driven by our innate curiosity. And hey, even if we don't find little green men or women, discovering even the simplest forms of life on other planets would be a game changer for humanity. It would expand our understanding of biology, evolution, and the potential for life in the universe. The search for life is not just about finding aliens, it's about finding ourselves. Section 9, to infinity and beyond, the future of planet making, well, sort of. So, there you have it, a crash course in the science of planet formation. From cosmic dust bunnies to planet-sized behemoths, the universe is a pretty wild and wonderful place. While we may not be building planets from scratch anytime soon, unless Elon Musk has something to say about it, understanding how they form gives us a deeper appreciation for our own place in the cosmos. And who knows, maybe someday, armed with the knowledge of how planets are born, we'll be able to create our own little corner of the universe. But until then, let's keep exploring, keep discovering, and keep asking the big questions. After all, that's what makes us human, and maybe just a little bit cosmic.